Hi, welcome to this page of the notes. Now what we're going to do is just continue this theme of solving absolute value inequalities, which means solving an and or an or inequality. Please feel free to work ahead and then come on back and check your answers with what we get. Now, checking out this first one, when I'm solving an absolute value, I remember I need to get the absolute value all by itself. And it is all by itself. There's nothing I need to move. The next thing I need to do then is, because it is an inequality, I need to figure out, am I setting up an and inequality or am I setting up an or inequality? Well, I remember back to the chart, which tells me which is which, and anytime the absolute value is greater than or equal to the number, it's going to be an or inequality. So we are going to be or, and let me write that so that I remember I'm doing or. Now the way that we write this is going to be taking what's inside the inequality. For x minus 7 is going to be greater than 13, or for x minus 7 is going to be less than a negative 13. And right away, again, I can see based on the way the inequalities are written, that these guys are going to be going in opposite directions, which is perfect. It's an or inequality. They shouldn't overlap. They should be going opposite directions. Let's solve both of these and see what we get. We'll solve them separately. We'll start here. I need to add 7 to the other side. 4x is going to be greater than 13 plus 7 should be 20. At least it was the last time I checked. And then we're going to divide both sides by 4. The 4 is positive, so I don't have to worry about flipping the inequality. You only do that if the number you're multiplying or dividing is negative. The 4 is positive, so we don't have to worry about it. X is greater than, and 20 divided by 4 should be 5. All right, on the other side, I'm going to add 7. Now, when I add 7 to a negative 13, I get a negative 6. Double check my work, make sure that that's right. Now I need to divide both sides by a positive 4. I don't need to worry about flipping the inequality. Negative 6 over 4. Make sure that we reduce that fraction. They both have a common factor of 2, which we can factor out. And that's going to leave me with a reduced fraction of negative 3 halves, which is approximately a negative 1.5. Negative 1.5. There's no way to write an or compound inequality in set builder notation. It just doesn't work out. So I now have my inequalities. We go straight to graphing them. Okay, let's see here. I think actually I can fit all of this on, so we're going to do 0. And then we're going to have 1, 2, 3, 4, 5, 6, 7. That should be far enough going in the positive direction. Let's go ahead and take care of this negative 1.5. So let's see here. There's my negative 1, negative 2, negative 3. That should be plenty far enough. Let me do this one in red. I need everything strictly greater than 5. Everything greater than 5. So that's going to be an open circle on 5, and we need everybody going that way. The next one is going to be, I need everything less than a negative 3 halves, which is a negative 1.5 guesstimated. I'm not going to go crazy on you here. It does need to be, oh shoot. That is my highlighter. Hold up. I can fix it. I can fix this. Fixed. All right. What we're going to do is I need an open circle at negative 1.5. That's right about there-ish. And then I need everything less than that. That's everybody going in that direction. And again, it's an or compound inequality, which means they should be going in opposite directions, like oars on a boat. Let's try the next one. Okay. Again, when it comes to these absolute values, I need to make sure that the absolute value is all by itself. And it is. So then the next thing I'm going to look for is it an and or is it an or? Well, I remember back to the chart, anytime I have the absolute value less than or equal to the number, we have an and. It's been a while since we've seen one of these. Let me go ahead and write it so that I don't forget. This is going to be and. And these are the ones that we can write all together and solve at the same time, which is awesome. I love these ones. They go pretty quick. So here's what we've got. I'm going to have the 5z plus 2. I keep what's already there. That is going to be less than or equal to 17. Then on the other side, because this one's less than or equal to, I need the greater than or equal to a minus 17. All right, well, now that I've got it set up, we're going to go ahead and solve this guy all at once. I'm going to subtract 2 from both sides. When I subtract 2 from a minus 17, that should leave me with a negative 19 less than or equal to 5z less than or equal to 17 minus 2 should be 15. And then we divide everybody by 5. Well, 19 doesn't divide by 5 evenly. That's okay. We will go ahead and get a decimal so that when I put it on my number line, I know where to go. And 15 divided by 5 should be a 3. Let's put this into set builder notation when it comes to these and inequalities. Set builder notation does work. So I will have the oh, yikes, that is a terrible bird. Here we go. My brackets. There we go. It is the variable z. It is all z's such that. Actually, let's get it now. So I'm going to take a negative 19 divided by 5, and we wind up with negative 3.8. So negative 3.8 less than or equal to z less than or equal to 3. Love it. There's my set builder notation. Close your bracket on the end, and let's get our number line. All right. Wow, we are going from, yeah, we got this. We're going from a negative 3.8 to a positive 3. We can fit all that on here. Let's start with minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and 5. All right, here we go. I need everything less than or equal to 3. Let's do this one in blue. Less than or equal to 3. There's my 3. Closed circle, so we're going to fill it in. I need everything greater than or equal to a negative 19/5, which we said is a negative 3.8. Guesstimate it. I'm not going to go crazy on you. Get it as close as you can. I think that looks pretty good right there. I need everything greater than that, which means it's going to be everybody in the middle. Pull out my blue highlighter. Shade everybody right there in the middle. And you have got your solution region. Remember, this is an and inequality, which means you pick any one of the numbers in the shaded region. It will satisfy both inequalities at the same time, all right? Only these are the solutions. It is the intersection between the two inequalities, right? This negative 3.8, everybody greater than that would be everybody going in that direction to infinity. The less than or equal to a positive 3 would be everybody going in this direction to negative infinity, right? But I don't want all of those numbers because not all of them will satisfy both. If I chose negative 5, it satisfies this one, z less than or equal to 3, but it doesn't satisfy this one because negative 5 is less than a negative 3.8, not greater than. And I must be able to satisfy both inequalities at the same time. And those are the ones that do it. Thanks for joining me for these problems on this page of the notes. Head on over to the next page. We'll get some practice with a word problem. I'll see you there.